So, congruent figures. We have our definition here of congruent figures, which says congruent polygons have congruent corresponding parts. Now again, what is meant by corresponding parts? In the same place. They're in the same positions. They're in the, all that kind of stuff. Yes, that's corresponding parts. And remember, it doesn't matter if the thing is rotated or not, right? So keep that in mind. When you name congruent polygons, you must list corresponding vertices in the same order. Meaning, if I am looking at this, we have this quadrilateral ABCD. If I had named that differently, because let's say I started at vertex C and I went clockwise, okay? So I named it CDAB. I could name this first one anything I want, but if I change the name of that one, I have to change the name of the second one. Because this statement is called a congruent statement. That's the official name. Ooh, let's get a smaller pen. There we go. Called a congruent statement, and I refer to it as the roadmap. I refer to it as the roadmap because a roadmap tells you where everything is. Well, that's exactly what that statement does. It tells you where everything is. So, meaning, angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G, and so on. They're in the exact same position in the name, okay? And so that means that those angles up here, that's how we named them. Those angles up here are the ones that are congruent. The roadmap is telling us that, okay? What about line segments? Well, let's look right here. Line segment BC. Well, just looking at the diagram, which line segment do you think it's congruent to? Yeah, FG is the one it's going to be congruent to. Hopefully you guys can see that this shape is just flipped over to make that shape, right? Okay, so those two are congruent. Let's look at where they're at in the name. Line segment BC is congruent to line segment FG. They're in the same position in the name. Line segment AB is congruent to line segment EF. Okay, let me erase some of that here so it's not so jumbled. But I do want to show you then, line segment AD, we can all see, just from the diagram, you can tell that that's going to be congruent to line segment EH, right? Where are they in the roadmap? Where are they in the name? AD, first letter and last letter. EH, again, first letter and last letter. They're in corresponding positions, not only in the shape itself, but in the roadmap, the name, that congruent statement. Okay? So that is what is meant to be congruent figures, is that all corresponding parts are then congruent. All right? So if we have quadrilaterals, that means we have 4 pairs of congruent angles and 4 pairs of congruent sides. If I have triangles, how many am I going to have? 3 pairs of congruent angles, 3 pairs of congruent sides. If I have pentagons, what am I going to have? 5 sides, 5 sets of congruent sides, 5 sets of congruent angles. So, let's take a look at our first example then. They tell us, they give us that congruence statement. They give us that roadmap. They say HIJK is congruent to LMNO, and they give us the diagrams. Now look at these diagrams. To make these two things line up, I have to basically take the second one here, flip it over, and then rotate it a little bit, right? And that kind of lines them up there. So if you're given a problem like this where they give you that roadmap, use the roadmap. Ignore the picture. Because you're just going to get confused. And, oh, well, angle O is congruent to which one? And, oh, then angle N is congruent to... so you're going to get confused. Don't do it that way. Use the roadmap. Okay? And so looking at that roadmap, angle H is our first angle. Angle I is the second. Angle J, I'm just looking at one figure. And then angle K. There's all four angles from the first picture. Well, angle H is congruent to which angle? Angle L. Why? Because they're the first ones listed. Angle H is congruent to angle L. Angle I is congruent to angle M. Angle J is congruent to angle N. Angle K is congruent to angle O. Correct. Okay? So now we can look at the line segments. Now again, I say go ahead and look at the road map. And just look at the first two letters here. So that is line segment HI. Look at the second two letters. Line segment IJ. Look at the third set of two letters. Line segment JK. And then look at the first letter and the last letter. Line segment HK. Okay, and you might want to just verify it for yourself that those are actually line segments in this diagram. Also, make sure that you didn't accidentally write down line segment KI. There is no line segment KI. Make sure you didn't write down line segment JH. Again, there is no line segment JH. All right, make sure you're actually writing down the line segments from that figure. So then, again, looking at that road map, line segment HI is congruent to which line segment?
LM.
Yes, LM. Line segment IJ congruent to MN. Line segment JK congruent to line segment NO. And line segment HK congruent to line segment LO. There we go. That's it. Okay. Questions? So let's take a look at the next one. Now for this one, we want to know, are these two triangles congruent? Okay, so in order to know that, if you look back at the definition of congruent figures, in order to know that the two figures are congruent, we have to know that all of their corresponding parts are congruent. So we're now dealing with triangles. So that means we should have how many sets of congruent angles? Three. How many sets of congruent sides? Three. So let's list that 6 pieces of information. And to do that, what I would actually do is start by just naming one of the objects. Give yourself something to look at, okay? So let's go ahead and name the triangle on the left side. You want to call it BCA. All right, good for you, Rebel. All right, so here we go. The thing is that triangles are special in the fact that they actually have a symbol for them. When you name a triangle, you actually use the symbol, like we do with angles, right? We have to have a symbol for an angle, right? Symbol for a triangle. Now, please pay attention. Make sure you get the symbol right. It's a hard one. And okay, so it looks like a triangle, so guess what it means?
Square.
Triangle, all right, it means triangle. Okay, so we're calling this triangle BCA. Okay, so therefore, we start out with angle B. And angle B is congruent to which other angle? Looking at the diagram. Angle D. They're marked congruent, absolutely. Angle C. Ooh, wait a minute, I can't say angle C. I can't, there's like 4 different angle C's. Which one am I talking about? I should be talking about this angle. The one that's inside that triangle BCA, right? How do I name that angle?
Angle BCA.
I can call it angle BCA. Okay? Angle BCA is congruent to, well, that would be this angle here, which we could then call, somebody else please. C has to be in the middle. You can call it DCE or you can call it ECD, but C has to be in the middle. Okay, doesn't matter which way you go, but C has to be in the middle because that's the vertex. That's what we're talking about. So those two angles are congruent. All right, and then we have angle A. And angle A is congruent to which angle? Angle E. Okay, and by the way, why was angle BCA and angle ECD congruent? We didn't say that. How do we know those are congruent? We had a vertical angles theorem. The vertical angles theorem says vertical angles are congruent. Okay? How did I know I could mark those little lines? It's because those are vertical angles. All right? Okay, so there's our 3 sets of angles. Now we got to talk about our 3 sets of sides. And so looking here, I have line segment BC. Line segment BC is congruent to which other line segment? BC is 4 units long. CD or DC, yes, either way. EC or DC. CD or DC, I think I said it wrong that time. Okay, so the next one we want to go AC. Line segment AC is congruent to CE. That's the ones that are 6 units long. And then our last one here, again, take the first and last letter in the name. So line segment BA is congruent to which one? ED or DE. Yes, whichever way you want to name that. Okay, because they're both marked with 1 dash. So yes, we have our 3 sets of congruent angles. We have our 3 sets of congruent sides. So by the definition of congruent figures, these are in fact congruent. We need to write a congruence statement. Triangle BCA is congruent to triangle what?
CDE. No, DCE.
DCE. It's easiest to look at your angles. Your angles will tell you what to call it. Questions? All right, so looking at the back side here, I want to start by classifying triangles. This, again, is something from probably middle school. You learned it at one time. You may not remember the details. So what is a scalene triangle? It has how many congruent sides? None. It has no congruent sides. Yeah. Scalene triangles have no 2 sides that have the same length. Okay, well, let's see. Isosceles triangles. At least 2. In high school, we say at least 2. And the reason is because equilateral triangles have 3 congruent sides. But all of the properties that we are going to learn in this class about isosceles triangles also apply to equilateral triangles. And so it can be said that all equilateral triangles are also isosceles. But not all isosceles triangles are equilateral. Okay? So careful on that one, but that's why we put that at least in there. Okay? Then I just said it, equilateral triangles have 3 congruent sides. So equilateral, lateral talking about line, so equal lines. Let's talk about classifying by the angles. So an acute angle has how many acute angles? Or acute triangle has how many acute angles? 3. Absolutely. All 3 angles then have to be acute for it to be an acute triangle. A right triangle has how many right angles? Can it have more than 1? Absolutely not. There is no way for it to have more than 1, because if I'm trying to make a triangle that has a right angle in it, I have 2 of my sides that make the right angle, I would have to put my 3rd side here to make it a triangle. Well, if I have a second right angle in it, there's no way for me to make that a triangle. I can't bend that to make it a triangle. Okay? So no, you can't have more than 1 right angle. How about obtuse triangles? How many obtuse angles can you have? Again, just 1. It's for the exact same reason I just talked about with the right angle. If I have 1 obtuse angle here, I can't have a second obtuse angle and still make a triangle.
Then it'd be a trapezoid.
Okay, I could make a trapezoid, but I can't make a triangle. Okay? How about an equiangular triangle? It's in the name, equal angles. Okay, so there are 3 congruent angles. And just for general knowledge here, then if there are 3 congruent angles, what do they have to measure? Well, adding them up together is 100, but not each of them. Each of them is what? Each of them is 60 degrees. It's the only possible answer. It's the only possible answer because they have to be congruent, which means they all have to be the same, and they have to add up to 180 degrees. So the only way to get that is if there's 60. 180 divided by 3. Okay? All right, good. Next, I want us to talk about these.
So was that one not all equilateral angles are 60?
Okay, now be careful. Be careful, be careful, be careful. Angles, all angular triangles have the angle measures of 60. But equilateral, we're talking about the sides, and we never use degree measures to talk about side lengths. And so an equilateral triangle, you could have an equilateral triangle, 1 centimeter sides, or you could have an equilateral triangle the size of the Bermuda Triangle and have it, many thousands of miles long for each side. Okay? All right. Let's take a look at these examples here. I want to give you guys about a minute with your neighbors to answer these on your own. Ready, set, go. Okay, so going through these, line segment QX is congruent to line segment NY. Angle Y is congruent to angle X. Line segment TA is congruent to. Can I call it OR?
No.
It's a line segment. I can name it either way. It's still the same line segment. Okay, got to be careful. I'm not actually naming the triangle. The triangle has to be named a certain way, but the line segment could be changed.
It's just easier to have one.
Angle R is congruent to angle T. Angle U congruent to angle A. Line segment DB congruent to
KL.
line segment KL or LK. Here, be careful. NDBA is congruent to
CKLU.
CKLU. All right, excellent, good work. Let's take a look up here at our third angles theorem. The third angles theorem says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles have to be congruent. This is 100% true because if I just assigned angle measures here, let's say this was 30 degrees, and let's say this was 90 degrees. Well, that means that E has to be 30 degrees and D has to be 90 degrees. What does the measure of angle C have to be? If I have a 90-degree angle and a 30-degree angle, this has to be 60 degrees. Well, again, looking at the other triangle, if I have a 90-degree angle and a 30-degree angle, angle F has to be 60 degrees, showing that those third angles have to be congruent. There's no other option for them, right? That's our third angles theorem. So, in the very few minutes left in class, I would like to walk through this proof. So we're going to do 2 columns. I'm going to abbreviate stuff horribly so that we can get through it quickly. And all of this is our given, which all goes right there. Okay. Not acceptable on tests or quizzes. Just saying. All right. So, we are given all of that information. We now need to talk about, do we have everything we need to say our triangles are congruent? Do we have 3 sets of congruent angles? Currently, no, because they only give us 2, right? The third set has to be this angle congruent to this angle. Well, I got to be careful how I name those. I can't just say angle N. I have to say angle MNL is congruent to angle LNO. Why is that? If I knew 2 angles and 2 sets of angles were congruent, how did I know the third set of angles were congruent? Third angles theorem. It's at the top of the page. We just talked about it. Third angles theorem. Okay. Let's look at the sides. How many sides, how many sets of sides are congruent? Currently 2. What's the third side? Look at the top triangle. What's the third side there that we don't know anything about yet? LN. Line segment LN. Look at the bottom triangle. What's the missing side there that we don't know anything about? Oh, LN. Well, how do I know that line segment LN is congruent to line segment LN? We had a reflexive property that we really hadn't used, right? Remember, angle A is congruent to angle A. Why? It's a reflexive property. Use the reflexive property. Line segment ST is congruent to what? Line segment ST. That was the reflexive property. Well, now we actually use it in proofs to prove our extra information we need. So now I know that triangle LMN is congruent to triangle LON by the definition of congruent figures.